Hello everyone, my name is Isa and I'm a teacher's assistant in this course, and I'm going to be making this tutorial for you in MIPS assembly programming in Mars. So in this tutorial I'm going to be programming a subroutine that I call reverse array, which is basically what it sounds like. It takes an array and it reverses the content. So if you, for example, have the numbers 1, 2, 3, then the result will be 3, 2, 1. And the reason for this is because it's quite similar to the assignment that you're going to make in MIPS, and hopefully you will get some inspiration on how you can solve the assignment after watching this tutorial. So this is the program Mars, and the first thing we're going to do is open our file. Let's see. So you open the skeleton file that you have gotten, and I've basically just made some changes to it. So when you open the file, you will get this edit section where you can write the code, basically. So let's go through it and see what we have. So if you remember from the lectures, this .text means that the following content in the file is instructions. So it's part of like the text segment in memory. And here we have the subroutines that you're going to make. Character count to uppercase, integer array sum, and here I have added my subroutine, the new subroutine I'm gonna make, reverse array. And the description is that it reverses an array of words. It needs 2 inputs. In A0 we want to have the address of the first word in the array, and then in A1 we want to have the number of words stored in the array, so we know how long the array is. And then I've just created a label here, reverse array, and made a comment to myself that I need to finish this subroutine. And let's go and look through the rest of the code. So below this line, in your assignment you're not gonna have to do any changes, but it can be nice to understand what's going on here. So here we have .data, which means that below this is it's data that's supposed to be stored in the data segment in memory. And I have added 2 things here. The first one is reverse count. So I created this label reverse count and the word. So it's basically just storing like the length of the array I'm going to work with. And this creates a word in memory, and this makes like the word contain number 6. And then I've also created an array to reverse. So this says that the following data is words, and I've created the contents of the array to be 1, 2, 3, 4, 5, 6. So quite easy. And then we have some other data that is used for printing and for the subroutines. Here is the main code, which basically just prints some strings and numbers, so you get the output when you run the program. You don't really need to understand exactly what is going on here. But in my case, I have added these lines just to like call my subroutine. So what this first line does is, this is the load address instruction. So it's going to load the address of this label. So each label is associated with an address, and labels are used to make it easier for us to program, so we don't have to like write the memory address, we can just write the labels instead. So if you remember what I wrote in the description of the subroutine, in A0 we want to have the address of the first item in the array. So this will load this address and put it in A0. The next line, load word. Now we don't want to have the address if I go back one step, if you remember in A1 we wanted to have the number of elements in the array, which was 6 elements. So in A1 we want to store 6. So now we instead want to load the data that is stored in reverse count. So this is going to load 6 into A1. And the next line is called a jump and link instruction. So this is going to jump to the reverse array subroutine. And then link, the link part is that it's going to remember where we are right now. So when we want to return from having finished reverse array, we can return here and then continue to the next step. And let's see. And then we have some other code to call on the other substructions, subroutines. Okay, so let's build this program. So in order to run the code, you first need to build, and you do this by pressing this little tool button. And after you've done that, you can now see the execute tab. So here we have the edit, we write the code, and here's the execute tab. And here we have, can see the memory. So this is the text segment, all of the instructions that we have. And this is the data segment, all of the data. And this is the list of all of the labels. So we can try and look at some of the data and instructions we have and labels. For example, we can perhaps look at this label, number end. So this label should reference this instruction on line 101. We can see. So let's see if it's correct. So we can look for number end here. Okay, so this is address 40000C. So let's look in our text segment. 400C. We have instruction 10 on line 101. Is that correct? Yes, looks good. And we can also find our data here. So for example, reverse count and array to reverse. Let's see if we can find it in memory. Okay, reverse count is on 1001 and lots of zeros. Oh, and it highlights it here. And this contains number 6, which is correct because I said that on this memory address we should store 6. And then array to reverse. Okay, so it's the same address but just a word next to it. So here. And here we have our array of words. We have 1, 2, 3, 4, 5, 6. So that looks good. And yeah, so that's how you can kind of use these parts of the execute tab. And below here we have some messages, like when I press the build, we got this message. And here we will have like the output from the program when we run the program. And over here in the corner we have the registers, all 32 of them, plus some other special registers. And now they're all empty besides this one, but we can try and run the program. Let's see. We can try and run the program. So when we run the program, we're going to go through all of these steps in the main part. And then we're going to come to reverse array and we're going to jump here to our subroutine. So let's try and run through our program until this line, and we can maybe just try and see that we have the correct data in A0 and A1. So let's see. So line 114. And when you run the program, you can either press this button. This will just run all the way until it's completed. But you can also choose to change the speed when you run here. Or you can also run one step at a time. Before we do that, I'm just going to add one line of code here. So in the end, when we're finished with our subroutine, we want to return back to the main part of the program. And to do that, we need to jump back. And if you remember from the lectures, we can do that by using jump registers and then jump to the register RA. So what is RA? If you remember down here, we used jump and link. So jump and link will jump to this label, reverse array, and link. And the linking part is that it will save in this register, RA, the current program counter. And the program counter keeps track of where you are in the program. So here it will be on this line, 233, so that when we jump and link, RA will contain the next instruction to go to when we are finished. Okay, so let's see. So 118. We can try and step down to this line. Let's just build first and start running the program. And now I'm just stepping one line at a time, and I'm keeping track here on the text segment till I reach 118, and then I know I'm in the part of the program where I want to be. Okay, so now we're at 118, which means that we are here. So let's check the registers. So what did I say? In A1, I want to have the address of the first word in the array. So let's see what's in A1. Here it is. So in A1 we have 1001,004, and it should be the address of the first element in the array, which is this address, which is correct, because here we have 1001 and lots of zeros, and then we add a 4, so that's correct. And what did I want A1 to be? A1 was supposed to be the number of words stored in the array, so A1 should contain 6. Let's see, yes, and A1 is contained 6. So everything looks good here. Let's look at RA perhaps, the return address. So here we have stored, let's see, 400D8. We can look at that instruction and see which instruction that is. See if it looks correct. Okay, so here it is, and it's line 240. Let's see what 240 is. Yes, it's right below reverse array. So after we have jumped and linked, when we return from reverse array, we will end up on this instruction, which is correct. Okay, so let's start doing some programming. So the algorithm I'm thinking of to do this thing, reversing the array, is that if we start at both ends of the array and we flip them, so for example, we start at the first item, which is a 1, and the 6, we change their positions first, so that we have 6 in the front and 1 in the last part of the array. And then we move, after that, doing that, we move into the next elements of the array. So we move into the 2 and 5, and we change place on those 2. And then we move on to the next place, to 3 and 4. And we keep doing that until we reach the middle. So the first step to do that is that we need to find the address of the first element, and we need to find the address of the last element. So let's see. Can do tab in, make it look a bit nicer. Okay, so the address of the first element, we already have it in A0. But let's move it to another register, because we're going to move it, or we're going to update the value to keep track of like the next element to change. So we can do that by using the move instruction. And the first register mentioned is where you want, like what the register you want to set. So let's write like this. So what this will do is that it will move the contents of A0 into T0. And if you remember, the T registers are the temporary registers. They can be used by the subroutines, but the data in them might not persist when we return from the subroutines. But that's okay, we're just going to use them now to reverse the array. And then let's write a comment. So in assembly programming, it's really, really easy to forget what you're doing, and so commenting is very important. I like to write a comment on almost every line just to remind myself what it is I'm doing. So after the instruction, we can write that tier 0 contains the address of the word in the front of the array. Okay, so now we have a reference to this this first element in the array, but now we want to have a reference to the element in the back of the array as well. And to do that, we need to find the index of the last element in the array. If you remember, the arrays are indexed from 0 and then going up. So the first word will have index 0, and then index 1, 2, 3, 4, and 5. So that to get the index of the last element in the array, we want to take the number of elements in the array minus 1. And we can do that using ADDI. And we want to store the result in T1. And what is we want to add? We want to add A1, the number of words stored in the array. And ADDI is add, but with an immediate, so you can write like a constant number here. And we want to have minus 1. Let's see. Let's just add a comment here. We're just finding the index of the last word of the array. So now if we have A1 contains the number 6, but we take it at minus 1. So now T1 will contain the number 5. And let's see. But now we want to find the how do you say, like the, so we have the address of the first word in the array. Now we want to find the offset to the last word in the array. And if you remember, each word is 4 bytes. So to move like to the next word in memory, we need to go 4 steps. And since the last word is on index 5, we need to move 4 times 5 memory addresses. And so we need to multiply 4 by 5. And we can do this with mul, for example. And we can store the result in T1 again. So let's multiply T1 with T1 and the number 4. And we can write a comment, the offset to the last word in the array. So now T1 should contain the number 20. And now to find the address of the last element in the array, we can just add this 20 with A0, which is the address of the first word in the array. And let's store it in T1. Let's see, so we want to add T1 with T1 and A0. And now we can write the comment that T1 contains the address to the word in the back of the array, maybe, or the word last in the array. Okay, let's try and run this and see if everything is written correctly. So we start by assembling it. And let's see, 119. You can also add breakpoints. If you don't want to like step through the program one by one, you can also add a breakpoint by checking this box. So I'm gonna add a breakpoint, oh, not here, here. And this is line 121. It's just before we return from the reverse array. And this is going to just work so that when we run the program here, it's going to stop here. So let's try it. Okay, so it ran all the way very fast. Maybe we can do it again, but a bit slower. Oops. Set a breakpoint. It's a little bit slower. Let's run it. So you can see it's going here and then it stopped when it reached this address. Okay, so let's see. We have done some things to T0. T0 we want the address of the first element in the array, and T1 we want the address of the word in the last in the array. So let's see what they contain. So T0 is this address, which is correct. And then T1 is, let's see, 1001, and then ends with 18. So if we go in this line, plus 18, we end up on this address, which is correct. Okay, so that was successful. Okay, so now we have the address. Now we address the address to this one, and we have the address to that one. Now we want to start moving the values. We want to move 6 to the front and 1 to the back. And we want to repeat this process all the way in towards the middle of the array. So let's create a loop. And I like to do this by creating labels for like the beginning of the loop and also labels for the end of the loop. So we can create one called reverse loop, perhaps. And we can also create one reverse end. Okay. And then we need to do some kind of condition logic to determine, should we do the things inside of this loop? Should we start changing the values? And so we need to do this by checking, have we reached the middle of the array? Have we reached this part here? Or are we still like here? And the thing that needs to be true, like we have not reached the middle as long as T0 is lesser than T1. So if T0 is smaller than T1, we want to continue. And if T1 is equal to or greater than T0, we want to branch. We want to not do the lines instructions under here. So what we can use then is a branch greater than or equal. Let's see here. Let's read the comments. So branch greater than equal, branch to statement at label if T1 is greater or equal to T2. So let's see. Okay, so that what this statement does is that it checks if T0 is greater than or equal to T1, then it will take this branch and go to this label, and we will end the loop because this label ends it. So if we have reached the middle, either by the first, like the T0 now points maybe at this address and T1 points at this address, then we need to stop. Or if they are equal, if, for example, we have an odd number of words in our array and they're pointing at the same element, then we don't need to change those values. Then we can also end the loop. Okay, so I think this should work. Let's see. Let's try a comment here. So if maybe just check if we have reached the middle of the array. Okay, so if we have not reached the middle of the array, if T0 is smaller than T1, then we will not take this branch, we will not jump down here, then we will instead continue on the lines below. So here we can write our code that changes place of the words of the array. So we need to first, in order to move this number 1 to the back and move number 6 to the front, we need to retrieve the data from memory. And we can do this by using load word, like this. And the first argument, we can write T2, and then, which is where we want to store the data we have retrieved from memory. And then we write offset 0, and here we will write the register T0. So what this does is that load word will go out in memory into the memory address in this register. So this is the address of the first element in the array. It will retrieve the data from there, and it will load it into this register. And the 0 here is the offset. For example, if you write 4 here, you would end up in 4 memory addresses. It's basically taking this memory address plus 4, so you will end up with the next word in the memory. But we don't need to use it because we know this is the address we want to get the word from, so we can just write 0 here. And we need to do the same for the word in the back of the array. So let's load it and store it in T3. Okay, and we can write a comment, the word in the front of the array, the word in the back of the array. Maybe we should execute this and try it and see if it works. So it's line 130, so let's build it. And 130, let's add a breakpoint here, and we can run it. Okay, so what we're expecting now is that in T2 we should have number 1. Let's see, there, T2 we have number 1, and in T3 we should have the number 6. Yes? Everything works correctly so far. Okay, so now we have retrieved the number 1 and 6 from memory. Now we want to store it back. So we want to store the 6 in this cell, and we want to store 1 here. And for that we can use store word. And the first register write is the thing you want to store. So let's store T2. So T2 contains the 1, but now we don't want to store it in the front, we want to store it in the back of the array, and that is the address in T1. And let's do the same for number 6. So in T3, we want to store it in the front of the array, which is T0. Let's have some comment. Store the first word in the back of the array. Store the last word in the front of the array. Okay, let's try that again. So now we can add a breakpoint here, 133. So we're going to build this. Find 133, set a breakpoint, and let's run. Okay, let's look in memory. So here in the front of the array we have number 6, and there we have number 1. So it's worked. It has worked. Yeah, so if in this case we're working with words, but if you're working with bytes, for example, characters in a string, you can also use load byte, which uses like the same syntax. And you can also use store byte instead of words. Okay, so what is the next step? Now we have flipped the 1 and the 6. And now before we do the loop again, we want to move our references so that in T0, the next thing we want to do is to work on the next element. So we want to have the reference here for the next element to the number 2 and then to the 5. And so we can do that by increasing this memory address in T0 by 4. So we can move on to the next word. And we can decrease T1 with 4. So take -4 to get the previous word. Let's do that. We're using add the. Let's see. So we want to update T0, and we want to take T0 and add 4 to it. And we want to update T1 with T1 and -4. Let's add some comments. T0 contains the address of the next word in the front, in the beginning of the array. T1 contains the address of the previous word in the back of the array. I don't know if that's a good comment, but oh well. Okay. We can try that one as well and see if it works. Let's add a breakpoint at 138. Adding a breakpoint, let's run it. Okay, so now we want T0 to be referencing this one. Let's see. Yes, it ends with 8. It's the address to the number 2 in the array. And this should be the address to number 5. It ends with 14. Yes, it's this one. Okay, so now we have moved so that we're now going to work with these two in the next iteration. Okay, and now we want to go back up here in the beginning of the loop. And we can do this using the jump instruction, which is just typing J, and then the label we want to jump to, which is reverse loop. Okay, jump to the loop. So now we will go up here again. We will check, is T0 still smaller than T1? If it's smaller, we will continue and move on to the next elements and flip them. And then it will continue doing this until we reach the middle of the array. Then it will take this branch, jump here to the reverse end, and just end this subroutine basically. So if I haven't forgotten anything, I think we should be finished with this whole subroutine. Let's build it and see if it works. We can have a breakpoint here again, 1:37, just before returning. So a breakpoint here. Let's run it. Okay, so now we are down here, which means that we have taken this branch at some point because we have reached the middle of the array. So we should be finished with reversing it. So let's see. Here we have 6, 5, 4, 3, 2, 1. Yes, it works correctly. Let's just test another thing. So here we have an even number of elements. Let's check if it also works with an odd number. So if we remove one, let's see if we have programmed it correctly so it works for this case as well. And we build it. We can add a breakpoint, 1:37. Let's run it. Okay, so now we have 5, 4, 3, 2, 1. Yes, it's working. So I hope this has given you some idea how you can do your subroutines. In your subroutines, you're going to have to work with arrays and strings, so you will have to do some kind of loops. So I hope you have an idea now that how you can do it using labels like this, using a branch statement, and having a label for where you should go when the loop ends, and having some code that you do inside the loop, and then at the end of the loop you can use a jump instruction to get back to the start of the loop here. And in your case, you're probably going to be using some other kind of branch instructions. There are so many of them. And if you need some inspiration, you can go here on the help section on help. And here you can find a list of all the instructions available in MIPS. So if you scroll down to the ones, starting with B, we have several branch instructions here. You can read and try and find something suitable for you. You can also go under the pseudo instructions and also find them here. A lot of different branches. In order to change data in memory, you can use store word or store byte if you're working with bytes. For example, characters in a string are only a byte. And you can also use load word or load byte to get data from memory. And the only thing to remember is if you're working with words and you want to go to the next word in memory, you need to jump 4 addresses. But if you're working with bytes and you want to go to the next byte in memory, you only need to jump 1 address. So 1 instead of a 4. yeah, that was it for this tutorial. I hope it has given you some inspiration on how you can solve the assignment. Good luck!